Today is Monday, October 14th, and this is Spring Office Hours, Season 3, Episode 34, Spring Cloud Data Flow. My name is Dan Vega, Spring Developer Advocate at Broadcom, joined by my good friend and colleague, DaShaun Carter. DaShaun, how are you doing?
I'm doing wonderful. It is a great time to be a Spring developer, and this is, just good times. We're having a good year. We've got great releases that have come out of Java, and we've got some really great stuff that's right around the corner with Spring Boot 3.4. I'm not the only one counting on the days, right?
Yep. And I think we talked about this last week, but I'm thankful it's not on Thanksgiving this year. I noticed it's on the 21st on the calendar. One of our favorite places to visit, calendar.spring.io. If you've never been there, check it out. You can see the release calendar of all the releases in the Spring ecosystem. I was looking at it and I saw it on the 21st and I'm like, yes. So we are going to actually have a show on that week on Spring Office Hours about that release. So yes, I'm getting excited for that.
Yes, we are. It's going to be good. And I'm making a trip to San Francisco just because Spring Boot 3.4 is so exciting. I'm going to make a trip. I'm gonna, I don't know what you'd call it. Yeah, just go and celebrate. Make a big deal of it because it deserves it.
I love it.
It's put in so much hard work, and it's going to be a great release.
Awesome. So you and I were traveling last week. We got to visit some customers. That was fun. How'd yours go?
I enjoy traveling. I enjoy doing what we do, and the conversations that we get to have with customers all around the globe are a part of our job, bringing that information back to the Spring team. And one of the things that it took me a while to get over, a lot of times I would just say, hey, I wish Spring Boot had this feature, or I wish other projects just had this feature. And I wasn't really doing anything else than wishing and, I'll go look for another project. But what our customers like to do, and what they get to do when we're there, especially, is they get to say, hey, this is the things I like, these are the things I don't like. And we take that information back to the Spring team. That's how we continue to make Spring better.
Yeah, and I think, just from an awareness standpoint, when you're in the grind of like building products for an organization, right? You're kind of in that daily, weekly, monthly grind of like, we're just trying to get stuff out, right? And so you hear about new features in Spring or new projects and you go, oh, that sounds cool. I just don't have time to like really understand it right now, right? So one of the things we talked about with a customer last week was Spring Modulith. And Cora did a wonderful presentation on it, and kind of a light bulb went off. And it's like, oh, wow, I didn't know that was what that project does and like what it enables us to do. And it was like just being able to like sit down with someone for an hour and talk about that. That was really cool. So.
And how many times do we hear that? Oh, I don't have time to sit down and learn about it. That's another one of the reasons why we like to do this show. It's to give you a little bit of a taste on these amazing Spring projects.
Yep.
So I'm thankful that you're here. And everybody that's joining, make sure to tell us where you're joining from. Say hi. My mom and dad like to watch the show, and they love to see where everybody's joining from. So let us know where you're joining from. Say hi. And when you come to my house for dinner, if you leave hungry, that's your fault. So you're here, especially during the live stream. If you've got questions, make sure you get them asked in the chat. And if you don't, that's your fault.
We're
here to help.
Yeah, and just as a reminder, we do this live stream every Monday from 1 to 2 Eastern. If you are unable to join us live, you can catch the replay on the Spring Developer YouTube channel. We also take this and turn this into a podcast. So if you want to take DaShaun and I on a run or in the car, we're all for it. You can get us wherever you get your podcasts.
All right, so if you are listening on the podcast, you should be all stretched out and warmed up by now. And let's go ahead and hit the start lap button and let's go. Today's episode, we're talking about Spring Cloud Data Flow. And we have a very special guest, my good friend, Corneil. Can we bring him in?
Let's bring him in.
There it is.
Hey.
Corneil.
Hi, DaShaun. Hi, Dan.
How are you doing?
Hi, everybody from around the world. I'm doing great. I just had a week at the coast. So I'm still making many typing errors. And, I did remember my password, so I'm good.
So fresh off of PTO.
But I created about 5 PRs today, so it wasn't
first day back from vacation, from holiday, and you pushed 5 PRs?
Yep. But they're all teeny. But that's how
they add
Chris
up.
and Glenn loves them. That when they teeny tiny.
Yes.
That's fantastic. But that's how we win,
I
right?
see we have many people from my close to my time zone, so that's good to see. Some people from Kenya, and there's some people from Nigeria.
Yeah.
Somebody from India is still awake. Oh,
We are
We're
a
lucky.
global show. Yes, we
Yep.
are very lucky to have people from all over the world joining us live. So that's pretty cool to see. Hey, for anyone who doesn't know who you are, can you just give us a quick intro to who you are, what you do, what you
Okay.
work on?
Yes. So currently I'm co-lead on Spring Cloud Data Flow. I picked up Spring WS when we lost some of the team members, and I've also now picked up Spring Cloud Shell. But those are well-established projects that don't need a huge amount of work, so I just press the release button now and then, and but I haven't had a chance to do anything meaningful there. Before this, I mean, I was a Spring user from the very early days. My first Spring app went into production at early 2005.
Wow.
And I was actually part of an internet banking system. It became the core backend. And I heard from the team a few years ago that I turned it into a boot app by just removing a lot of XML config and slapping in starters, and boom, there it goes. So that's the beauty of Spring. It actually gives you longevity like nothing else, and I think that's part of the whole Java ecosystem, is this longevity that people don't realize. It's become a challenge because we were stuck on Java 8 for a long time, and now all of a sudden it's popped a wheelie and off in the distance, and we just have to hang on.
Popped the wheelie. It's popped the wheelie, and it can be hard to keep up.
Yep.
Right?
Yep.
6-month release cycle.
But they're still not breaking it for the existing users,
Yeah.
which is what it's all about. I look at some of the other ecosystems, and I just
If that was easy, all of the other languages would be doing the same thing.
Yep.
Right.
But the thing is, you have to make it a priority. Otherwise, you're going to hurt your users. And Java is a fantastic example of how do you maintain backwards compatibility, and how do you actually show your user community that you have respect for them. Because I think it's disrespectful to make changes that just force them to jump in and rewrite a lot of code.
Yep.
And nowadays we can't afford to just deploy the code and forget about it, because everybody's on the CVE train. They've got something that's scanning the code, and especially if they've got one of these modern tracing system installed that actually finds everything that's running, and they're like, oh, we didn't even know this thing is still running, and now they go and scan it, and then they have to go and find out who owns it, and then that person gets hit over the head with a Excel spreadsheet full of CVEs.
Yeah, I'm not saying that I've ever done it, but how many apps are running in production somewhere that didn't even have a Git repository? They were just something that somebody made. Right. I'm not saying that I've done it. I'm just saying.
No, I mean, for me, that one of the first things I spent money on when I went freelance is MKS. That was in the early 90s. I bought Turbo C++ and I bought MKS, and that was a big chunk of money for me then. But I just decided it's not worthwhile throwing away what I've done if it's so easy to keep track of it.
Yeah. Today we're going to talk about Spring Cloud Data Flow. You've got a ton of experience, and not just experience. The cool thing is I've known you through the social media and things since before you were even on the Spring team. You are another example from my perspective of somebody that was doing great things in the ecosystem. that found themselves later on the Spring team. So thank you for all of your contributions on
Absolutely.
this team and before being on the team.
I mean, the welcome I got when I joined the team was overwhelming. I was actually, I showed my wife and she couldn't believe it because it was just people coming out of the woodwork that I'd forgotten, and I basically had one interaction with them, but it lasted, and so I feel very welcome, and the team is great. I mean, it's just an awesome team of people, and we love what we do, and I think there's plenty of people who probably deserve to be on the team because they make great contributions. But we're surprisingly small team. We had a chat with a customer in the UK, a potential customer. So they're on one of these big integration systems, and they run thousands of these integration flows, and they want to move off this tool because it's costing them a fortune. And they find that half their work is workarounds. In other words, to get past the limitations of the tool, because when you have an integration tool, it's got boundaries, and you're stuck with those boundaries. And they told us they have 10,000 developers, and I just couldn't fathom what do you do with. Well, if you've got 2,500 teams of 4 each doing an integration flow or a few flows, because it's all logistics and supply chain and that kind of stuff. So it's all these different systems that have to interact. And how do you keep track of it? How do you? And they were keen to ask, well, how many people are on the data flow team? And we said, no, 2. And they said, oh, 2,000? No, 2. So it's interesting to see how people solve problems and what approaches they take. But yeah,
that's yeah. I think you just said something there that kind of struck me. Like, it's interesting to see how people solve problems. One of the things that I constantly am trying to stress to people is, like, before you jump in and learn something, like, you got to understand, like, the why. Like, why am I learning this thing? So I think I want to start there with Spring Cloud Data Flow. Like, what is it? But what problem is it trying to solve? And I think we can kind of work from there.
Well, we've had one. We talked about it before. We talked about Spring Cloud Data Flow being kind of the de facto UI for Spring Batch. So let's start.
Well, in fact, you have to add Spring Task to that batch, because Spring Task is the thing Dataflow understands.
Okay.
It can launch the task and it can track the task state. And the task will just sit there until the batch job finishes. And then we will find out, oh, that task actually had a batch job inside, so we can tie the two together and we can show you the details. And you can draw in and you can restart the batch job if it's failed, which is powerful, because if you had 10 million rows to import and it failed a third of the way or 2/3 of the way through, you don't have to redo those because it tracks the state. So that's the power of that. But the other thing that people forget is that, or not aware of, is that you don't have to have these scheduled jobs. You look at this and, okay, this job is never taken more than an hour, so we'll schedule the next job for an hour later. But you can actually use what we call composed task runner. So you don't use it explicitly. You just define a job with multiple steps, and you can define them in sequence or in parallel. And you can define essentially a branch to take when something fails and things like that, which means that all the jobs will finish when they need to, and the things that can run in parallel. So that's something very powerful, which allows you to optimize your resources, because oh, these two, I would love to run them together, but they're both big, so I'll put them on one after the other, and or you can, through your monitoring, discover where, no, we can actually run these in parallel because they don't use that much resources. So there's an aspect that's quite powerful. But then the other part of it is streaming. So you can now essentially wire together a series of workloads related to events. So something that produces an event, something that processes that event, and you can have multiple of them. And then you can have something that handles it at the end. So we call it a source and a processor and a sink. And these originate, we didn't actually just pull this out of thin air. At that time when they were looking at how do we build this functionality, the Java team had designed these abstractions for function and consumer and the producer. And it's a great match. So we have a thing called a binder, which understands these things. So if you want to build a source, you bind to a consumer, to a producer, sorry. And if you want to create a processor, you bind to a function or a set of composed functions. In other words, they follow each other in a row. So you can actually package many functions in one processor, and when you deploy that, you can tell it which composition you want to use. So you can actually change the composition of functions that that are invoked, because I/O isn't free. So if you have to persist between each of the functions, there's a cost associated with it in terms of this thing must be persisted. You have to wait for it to happen, and then it gets read off again. And if they're all in a row, then there's no extra I/O and obviously reduced latency. And then your source is a consumer that you bind to.
I feel like you're looking at my old Git repositories and you're calling me out here. I feel seen, where I had these tasks scheduled throughout the day so that they didn't run over each other. Maybe I've done that once or twice.
You see, and that's the thing is you have to spend a bit of time to dive in and work through everything, and not just, oh, this thing does what I want, and then go off, because the next paragraph we say, but there's more.
Yep.
So you can come back and you'll find out there's more. There's another thing that people are not even aware of, and that is that we have a plugin that you can attach to your project, and then you can create a property file that's actually called, I think it's called dataflow configuration.properties. And in there is a list of class names of your application or your processor or whatever's properties. So you can, remember, you can take a Pojo and annotate it with @configuration properties, and you can add a prefix for those properties. And then you on your application, you add enable properties, and then you bring in all the property files that you're interested in. And auto configuration will bring in a lot more, but those that you list in that file will get packaged as metadata. So this plugin allows you to package it as metadata, and you register it. So if you're in the UI and you say, deploy the stream, you can see your own properties listed there with the comment above it is there. And if it's an enum, it'll show you the options. And so if you build something that's to be used by other people in the organization, you can package it really professionally so that they can use it. They don't have to read your code to try and figure out the properties. The metadata is there, and we have ideas for improving it so that we turn it around, and the only thing you register is the metadata. And then the metadata also tells us where to find the application and everything else.
That's
you see.
cool.
So, because at the moment, you can bring two things. You can bring a Maven jar, which a Maven coordinates to your application jar. So you've built it and you've put it in a repo, and you can provide those coordinates. Now, if you're deploying to Cloud Foundry, that's beautiful, because the deployer will pull that jar and tell Cloud Foundry to do its thing. So it then does a CF push with the other stuff that we've added. If you and we don't advise you do this for production, but you can run it in what we call a local mode. In other words, everything's on one machine.
Yep.
Spring Cloud Dataflow Server, Spring Cloud Skipper, and then it will just launch the processes. Now, there's some people who do that because they have a batch job that's huge, and everything's on that machine, and they launch that batch job, and there's a dog at the door that bites anybody who wants to touch the machine. So that's and for them that's a valid case. But for most people, you're not running batch jobs all the time. You want to maximize your resources. So then you will have a platform where you deploy to, and it gets used on demand. So in the case of Kubernetes, you bring the Docker coordinates of your applications, whether it's tasks or processors or sinks or sources or whatever, and it will pull from there and then deploy. But you also put your metadata in your own repository, and then somebody else can orchestrate the work, because they can do multiple different things. We had a use case that we thought up, which was basically somebody running advertising campaigns, and you could have something. So I don't know if the API is still good, but Twitter has an API that used to be free, and then it got limited, and now I think nobody can afford to use it anymore.
That's correct. I've tried that before, so yeah.
You could pull off data, and then you could use that to decide what do you want to do in terms of messaging out the other side. So if there's a lot of noise being generated, then you can stop making noise, or you could run campaigns in related to, for example, sports events, and as the crowd leaves the stadium, you hit all the shops in the vicinity with, who knows, various things. Yeah. So it gives you the tools to have something that's been tested and done professionally, quickly put together, and you're up and running, and you can do interesting things.
Interesting data workflows, right? You took it from, hey, here's batch, and then kind of the natural evolution of those conversations is, let's talk about streaming data and all the ways that we can do that. And for a long time, every time I saw a batch workflow, I was like, oh, why isn't that streaming? Why isn't that real time? These things are complex. Wouldn't it be nice if you had a data platform that could do both, right? And make a decision.
Yes.
Like, oh, I got this time 4 trillion records.
Exactly. So for example, let me give an example. You could have a situation where you have an S3 bucket that you're using the S3 source to look at. So when a new file gets dropped there, it can pick up the file. Now, what you want to do is, if the file is small, then you want to just use it as one message for the stream. Or you could break up the file into separate events, especially if that's how they're going to be processed. But beyond a certain size, batch is king, because if streaming is one transaction per event essentially, or multiple depending on how many hops you have. Whereas with batch, you can do multiple things in one transaction. And but you could now have something that picks up just the file reference. Then you can have, so you can take our stream applications S3 sync and you can tailor it to your needs. So you can basically say, okay, I'm going to change it so that I'm going to give it a threshold value. And if the file is below the threshold, then I send the contents. And if the file size is above the threshold, then I just send the reference and I add a header to indicate which of the two. And in the one case, it goes to our task launcher sync, and that sync will launch a task, and the task gets the reference to the S3 bucket, and it goes, well, batch job. In the other case, you have a processor that does the same work as the batch job, but the file's in memory, and boom, we do all the work, and we just finish it up there. And or it can actually be a sync that's actually a batch job embedded, and it quickly runs, but it doesn't shut down when it's finished. So it runs the batch job and then it waits for the next one. So there's different things you can do. Nobody says you can't organize these things. So the interesting thing is that some integration tools are obsessed with what your data looks like. And they invariably run into trouble because you're gonna hit the limitations of what they thought up.
Yeah.
Dataflow doesn't care about what your data looks like. To Dataflow, it's just in general, it's just a blob. And we pick it up and we pass along everything and we hand it over. Your specific processor or whatever is the one that's interested in what the data looks like and what you want to do with it. We're just going to preserve it.
Yeah. Spring integration. If I'm comfortable with Spring integration, Spring Cloud Dataflow gives me a lot of flexibility. I can start to use some of these building blocks that I was doing in Spring integration, and I can connect them together.
Spring integration is how you build that application. And then you must just remember that there is this nice thing called bindings, which means you don't have to, there's some stuff you don't need to do. But if you're doing, if you're not consuming a stream, in other words, you're the source of the data, then Spring integration is absolutely your friend because it's got all the tools for building an integration flow and putting everything together and then producing a message that goes somewhere.
The number of bindings and connectors that are already available continues to grow. We were talking last week, I think, with Chris Bono, talking about streaming, and he was like, "Oh, somebody asked about one of them," and he's like, "Oh, yep, that collector is already there." So that's amazing. But this whole thing,
I see we have a question.
Yeah, the last one
about Apache Camel.
Yes,
so Camel is much more like Spring integration than it is like Dataflow. Right. Because Dataflow is the orchestrator. So it's a thing that orchestrates these jobs, these applications, and you can enable metrics, and they get pumped out the other side, and you can have Prometheus and a Grafana dashboard or whatever. There's a long list of metrics that we support. And it is your dashboard into what's happening. So it's up to you when you build the application to make sure that you publish the metrics that you're interested in. And then you can add your own little addition to the dashboard. You can customize it, or you can add your own dashboard for that app, for example, to monitor certain things. And but it ends at the process boundaries. But it has some visibility inside because of the task publishing its status and the metrics that come out.
I've done Spring
And that's
integration. I had,
Mm.
a workflow, a step number 5 of 20 was actually a bottleneck, and it was causing problems. So I had to scale out my Spring integration app in order to resolve this bottleneck. But one of the differences, another key feature, correct me if I'm wrong, about Spring Cloud Data Flow is that I can scale these different building blocks independently.
Yep. So if you have this case where this thing might be the one that needs to scale up, then it needs to be separated in a separate process, because you can now take that processor, for example, and you can say, I want to run more instances, and then it will run more instances. In the case of Rabbit, that's easy because it'll just scale up. With Kafka, you need a bit more knowledge of Kafka before you do, because it's separate partitions and you have to provide a partition key, and then it will scale up based on that. And then you've got multiple instances of that specific, whatever it is, source sink or processor. It's usually a processor or a sink
IO,
that's,
right? IO
that's
isn't free.
suffering.
Like you're calling me out again. I've abused databases. I've abused sinks for all different types of things that they shouldn't be used for. But this gives me a little bit more flexibility. Right?
Well,
go ahead.
Oh, sorry. And along those lines, we had another kind of question around that. Is there any possible use case of leveraging Spring Cloud data flow with virtual threads?
I don't really see that case, because we're usually dealing with one event at a time.
Mm-hmm.
So if you go look at the code, and if the code's already reactive, then it's probably going to be able to benefit from virtual threads. But a lot of it is aimed at single events that need to pass through. It's the same thing with I don't know if you know. Oh my goodness. Now I need to remember the name. Man, it's a tool that Martin Thompson built to do high frequency trading, and it had a short double barrel name as well. I'll get to it now. But that tool works by literally having a dedicated thread per, let's call it flow. So data comes in, runs through, and at the end of that flow, there's a lockless queue that is, or there's many lockless queues.
Was it Aaron?
Well, Aaron is part of it, but there's LMAX. LMAX Disruptor was the original. Okay. So LMAX basically had these dedicated threads. So if there's the CPU has 8 cores, you had 8 threads, and each thread did work, and the work was distributed amongst them using these lockless queues. And by having code attached to the thread, you just get the throughput, and they just made sure that they never get off that. Now, if you have a web front end that supports an API with multiple request types, you can't predict what's going to be what. So you need something that can handle them on demand, and then virtual threads or reactive a model in WebFlux is your friend. But once you know the workload, then you want that workload tied to a processor and run flat out. And what you do want to do, and that's something that's on my menu for the future, is how do we scale to 0 on a stream?
There you go.
Okay.
Yes.
Because having that stuff sit there and just wait costs money. So how do we scale to 0? I've been playing with which of my stream apps can I make native. I made one of them native the other day. Man, it's the weirdest thing to see this 40 meg app sit there and it flies along. and the old things sit there, and they want 640 megs of RAM
Yep.
before they do anything.
Yeah, while they're sitting at idle. You're addressing a couple of questions though here.
Yes.
One is like, hey, and we get this all the time. Is this virtual threads going to replace the reactive style of programming?
Not in my view.
I don't think so either.
In my
Right?
view.
You kind of.
I believe, because with virtual threads, you're never going to have that whole mechanism to let the upstream know that I'm overloaded, which you can push right back into the router and into the network layer. Whereas with virtual threads, you are just going to fill up. You just have a cheaper thread pool. That's all you have, and you don't have a way to actually say, well, if you have a proper reactive setup, you can the load balancer can say, oh, this guy's actually busy, let me fire up something else. With virtual threads, he won't know unless you're actively monitoring the number of virtual threads, which is the wrong thing to do if you can just get an event that says So there's for me, reactive's never going to go away because it has some very powerful scalability mechanisms.
Yeah, I think one thing I've been kind of talking to people about, especially this year, is if you reached for something like reactive programming as simply a scalability mechanism, then sure, virtual threads can solve that. But if there are other things dealing with back pressure, the things that you mentioned, right, that are going to keep reactive programming around. But
but then
if I really need to deal with 1 million users, then reactive is the way to go. But if you're going to have 30,000 users max, virtual threads will probably do fine, and that instance may hold up or may not hold up, because invariably something downstream is going to croak. So but with a back pressure, you can protect the thing downstream. Which is what it's about. I see we've got a question about context between the different tasks. So there's, when Dataflow launches something, it assigns it an identifier, and it gives it a set of parameters. So if it's a task, that task gets launched and it runs, and the task gets assigned an ID, and the task knows the ID, and that's how it publishes its data. And if you use an API to launch the task, you can get that ID back, and you can use it to track that ID. Well, in fact, what you get back is not just the ID. You actually get a nice Hatios package with a self link that you can use in subsequent events and queries. So we just assign an ID to each and track it from there.
That's fantastic.
How much load can Dataflow handle? Dataflow just gets out the way. It depends on your infrastructure. So Dataflow just launches the application. So if you're running on a single Raspberry Pi, then you're going to need you can use a calendar to monitor your workloads. But if you've got
wait a minute.
I'm not bashing Raspberry Pi. It's a good work. You're going to get some work done.
Yeah.
But if you expect a lot of things to happen, then you must throw a lot of hardware at it. We give you the tools to measure your throughput, to measure your memory consumption, to see what the problem is, and then to figure out how to scale up. But and we help you in that scaling up. But Dataflow,
in order to squeeze more performance out, get on the latest version of Java, get on the latest version of S3 for your
and that's
workloads.
The interesting thing is, even though Dataflow, that the current release 2.11.5 is built on boot 2x, it allows you to run boot 3 jobs. And if you create if you run Dataflow's containers, we have a Java 17 container for Dataflow 2.x, and we don't care what your runtime is, as long you just have to tell us whether it's based on boot 2 or boot 3, because there's differences in how the properties work that we need to take care of. But for the rest, we get out the way, and it's up to whatever you've brought to the party.
You just gave me a really, really interesting thing in my head. Like this whole, like, hey, I've made these workloads, I've made these tools to do certain things. And I happen to be dealing with a lot of customers where library thing that they are pulling into their application was built on older version, Spring Boot 2.8 or 2.7, or the other way around. And they're having these compatibility issues. I can't use that. But what I just heard you say is, even
we allow you to run both. Yeah,
I can still execute, and I can trigger those Spring Boot 3 workloads or Spring Boot 2.x workloads.
Yep.
This is a really interesting thing.
Yep.
This is another.
Look, on the next version, that's going to go away. So
on the next version, are we talking Spring Cloud Dataflow version
3?
3? Fantastic.
So it's going to be, and in fact, it's skipping boot 3 altogether, because we have to launch in line with boot 4 and framework 7. So
I don't think you were supposed to talk about Spring Boot 4 yet in public. We've got the scoop.
Okay. I thought there was
there's a blog post.
Okay.
Yes,
there's a blog post. There's a blog post.
Yep.
No, there's a blog post. I retweeted the blog post, and but that's nearly a year away.
Yep.
So we've got a year to do something special. We want to find ways to improve the user experience, to make it easier to build that metadata, to make it easier to build native apps, because even though
I don't get a bigger budget next year. I don't know about you.
No, nobody's getting a bigger budget, but they want to run more.
Yeah.
So
do more with less.
If you can go native, then you can get a lot more done on the same hardware. But you have to understand where native benefits. If it's something that's IO bound, native's going to be fine. So most workloads that people use Dataflow for, you're probably going to be fine. But if you now one of the nutcases who's decided, no, I'm doing machine learning and data science in Java, you're welcome. It does well, but you're going to have to give it resources, because that jet has to get time to optimize. And you might put your application on crack, and that's how you run your processor. But the rest of the other stuff can be teeny weeny, moving the data around. So you've got all these choices in what you deploy. And the idea is to build the work as libraries, and then decide the topology, the deployment topology afterwards, because you don't know what you want to put together. And if you specifically take them apart, then you're always going to pay the price for them not being together. So always build a library of your functionality, and then just a separate app that you package it and configure. And
so I wanted to pick up on something you said. You said you are always looking for feedback. So if developers, if customers are using Spring Cloud Dataflow, what is the best way to get feedback to your team, so you guys understand what developers are doing with it, and what they want to improve with it?
Yeah. So at the moment, we monitor Stack Overflow. I have asked for us to consider enabling the GitHub discussions, because I believe it's valuable, but we haven't made a decision around that yet. We may have a GitHub discussions that's the whole of Spring Cloud. That may make more sense, because a lot of these things overlap. You don't want you don't want to have 30 discussions that nobody sees.
Right.
Whereas Stack Overflow, people post and they tag Spring Batch and Spring Data Flow and
but that
something
flow still
else.
works, right? That's still an option.
And then yes, so we monitor Stack Overflow and we try and give feedback, and we invariably create an issue from that if it's warranted, or we ask the user for please collect more info and then come and create an issue. So, but we're actually surprised about how few issues we get and how large the community is, because one of my questions when I joined the team was how many people are using it, and I got the numbers from the commercial side. So these are people who are paying for what is now Tanzu platform for Kubernetes, or Tanzu platform for Kites, and we saw those numbers, and those numbers were low. It was a few hundred, if at all, but they were doing huge work. And then I asked for what's the Maven downloads, and we couldn't get those. And then I happened to notice on Docker Hub the number of pulls on, because we publish our containers to a repo. And there's also a Bitnami team that creates a Helm chart, and they create separate containers. And the combination of those two over the last 5 years has been 15 million pulls.
Wow.
Which means that we have somewhere at
There's-
least
there might be a few
100,000,
people.
maybe 500,000 people who are actively using it.
There might be a few people that are using this. 15 million pulls.
Sometimes I think
subtracted all my acceptance tests, and it's still a lot.
Yeah.
Sometimes people may not want to submit issues on things they're not clear about. So if I don't use Stack Overflow, but I have like a question about how something's working, I think it's perfectly acceptable to file an issue.
Add me on, create an issue, or add me on Twitter or whatever.
There you go.
Because
Well, I'm pretty sure that's how you and I met. I think I asked you directly something on Twitter, and you gave me a solution, and then I, fan forever. So that makes sense. When you brought up the Bitnami Helm charts,
yes,
that's cool. That's what I leaned into earlier today. Those are freely available. And the other thing was, the microsite. Spring Cloud Dataflow, unlike a lot of other projects, has its own microsite. How did that come about?
Well, it happened before my time, but the thing is, what you must remember is most of the other projects are just libraries. So there's a library, there's documentation, and that's it. But Dataflow is a product. We build stuff that goes out the door. So we have to be a bit more gentle, because our audience is maybe slightly different. And a lot of developers, they will pick up Spring integration and build their stuff, and off they go. But they forget that how do you watch this thing? How do you deploy it? How do you monitor it? How do you manage all these things? How do you manage the life cycle? How do you do upgrades? These are the things that may not be important to the individual developer, but it's important to the organization. And I think the Dataflow was an attempt to package all of that in a way that was not really possible on just docs.spring.io. And we now have the challenge to update the microsite to integrate with Antora-based documentation, which we will have to do for the next release, so that you have a drop down for versions and things like that. And we will probably move more of our content onto the reference guide and just link to it. And
I'm a big fan of the microsite, like the accessibility, the tutorials that are there, the way it's laid out. I'm a huge fan.
And we don't want to break that. So we want to find a way of keeping it accessible being able to tell the story, and making it easier for people to pick up and go. And we now have a one-pager and a set of scripts. So you can install Minikube, and then 2 minutes later you can have Dataflow running. And if you have a fast network connection, otherwise you need to wait for the pulls. But so there's a lot we're trying to do to improve that side, and we would love feedback from the community, especially people who's actually used it.
Or people that have used
you,
Camel, or people that have used
yes,
MuleSoft.
yes.
Like there's other tools.
Yes,
play nice.
Because what will invariably happen is they will say, I want to be able to do this. And then we can say, well, this part belongs into Spring integration, and there it is. Or I'll go and tap on Artem's shoulder, and he will build something, and next release of Spring integration, we have that capability, and then Dataflow is the way to orchestrate it. So
you're saying feedback is valuable and welcome.
Absolutely. I mean, the community means nothing without the feedback.
I've heard a word mentioned a lot of times today, and that is orchestrate. So now I'm picturing Corneil and the Spring Cloud Dataflow team as the conductor of the symphony that is your application suite. So
I love that metaphor.
No, we write the music. The user's the conductor.
There you go.
That's the thing, is because they can go in and they can now do something relatively simple to put it together. We've done all the hard work underneath.
And the thing is too,
and the next thing is how do we improve it? How do we make it easier to consume? How do we improve the dashboards? Because now we have metrics and we have traceability. So
there's two really good observability demos, tutorials, how-tos in the reference guides. But the UI. The UI here allows me to take these libraries of connectors, processors, syncs, and I can tie them together. I'm not building XML to go and put these flows together. And I think it's a really great UI to build these workflows and chain these workflows and connect them in different ways. And you get to talk about how awesome the UI is.
Yeah, and you get like all these like starter applications, right? Like you don't need to start from ground zero, which is really good.
Exactly. And if you don't like how they work, they're there. You can pick them up and you can change them, and you can discuss your change with us. Maybe submit a PR and we add that capability because it's useful to other people, or you run your own version, and you can go with it. So, I mean, I've got the vision that part of the next generation might be that you don't just register apps, you register a function, and you tell me where the Maven coordinates of the function, and you then orchestrate functions, and then we analyze that graph and decide what is the best way to deploy this. And then we package those functions. We dynamically create apps, and we quickly build them in a container and publish them and deploy them. And then you don't even need to build the app. You just build the functions, because it's possible. Because a lot of those, you can go look at those stream apps. Some of them have no Java code there. The Java code's in the Spring Functions catalog. So you'll have the catalog there, and then you can bring your own, and that could be a next level of making it easier to use.
Great question. Like this seems like, right up your alley. 2 scheduled tasks running in parallel in Kubernetes. Started 2 pods. Is there a way that one task selects the first 10 and the other It's the next 10.
Oh, we have a mechanism with a batch jobs that that you can run. You can scale them up, and you tell batch about it, and then it will interleave those jobs. So they will basically
take the next one up.
do that kind of thing without stepping on each other's toes. So it's part of the batch configuration.
Yep. And if one of them goes wrong, we have the retry mechanism, and that retry might not land on the same pod, and that's okay.
Yeah. And you can, if at the end you see there's some that failed, you can just say restart, and it and it'll rerun the parts that failed. So that capability is there. I am not the batch expert. I mean, the batch expert is our big boss, but Glenn knows batch very well.
Yep.
And
Glenn has been on, and we've talked about batch. And if you want to check it out, check out our previous episodes around Spring Batch, Spring Cloud Task, etc. But yeah, these are great questions, and this is definitely where you want to bring those questions to. We want to give you access to the Spring team, to people like Corneil that are putting those bits together and building the next release. Corneil, I want to say thank you so much for coming on the show and hanging out with us. And what I would like to do is I'd like to invite you back when Spring Cloud Dataflow 3.0 doesn't get to release, like when we get a release candidate, like come and let's talk.
Oh yes, look, that we are planning to put out a milestones and a release candidate, and I personally feel we should do a 3.0, but it puts extra load on the team because it's an extra line that needs to be maintained for a number of years. So so the decision making about releasing in November next year is around getting everything in line, so that batch, data flow, work, framework, cloud, everything goes out at the same time with the same version support. And so we're starting the new journey, and we have a lot of time to do interesting things. So we'll see what comes out. So that feature that you asked about is actually called partitioned batch jobs. So you have partitioned batch jobs, and it will do that work for you. So you can really scale up your batch jobs easily. And that's something that's difficult to do by hand, because you now have to figure all this out. And instead of Dataflow going, oh, I know this, and does the work for you.
This is amazing. Next time you come on the show, I will have my Raspberry Pis ready with Spring Cloud Dataflow installed, and we'll see what kind of.
We'll figure out how to build native ARM apps for them. And,
there you go.
Spring Boot 3.4,
and see how much work we can make them do.
Yeah, native ARM images. The architecture build pack is coming included in Spring Boot 3.4. Only a couple of weeks away.
That's why you're so excited.
You could see his eyes lighting up.
I don't have cloud money. I have Raspberry Pi money. So
many people are realizing they don't have cloud money.
Yes.
They're like, no, throw it in S3 and then we'll just get it out. And then they get the bill and they're like,
Ingress, yes.
How does this work? Oh, there's this word called egress. And So
yeah, well, thanks again for coming on the show today. How can folks stay in touch with you if they need to reach out and ask you a question, or just say thank you?
They're welcome to add me on Twitter. I'm at Corneil. If you go on the Spring team, I think it's spring.io/team.
Yep, I'll get that in the show notes.
You'll see my mug there, and then just click on the name below.
Okay.
And yeah, I'm active on a few. There's some community Slacks, like there's a Java specialist Slack where I'm active. I'm on the Kubernetes Slack because I watch things like Helm and Kates and Carvel, and I'm active on the Kotlin Slack. So
Nice.
We also package this as Carvel,
Yes.
package. Yeah, thank you so much. Thank you for all of that.
Awesome.
I'm a
All
fan.
right. Thanks, everyone. Thanks for showing up.
There's somebody
and-
who put my name.
Yep.
Oh.
I put your
So you've
Does
got
DaShaun.
me, Java Grunt. I will find out who you are.
That's me.
I didn't.
That's me. That's another
Okay.
channel. Yeah.
You're welcome.
I didn't even know X.com existed. I still call it Twitter. So
I call it Twix.
Twitter.
I like Twix.
No,
All right.
Yeah.
All right.
Yeah.
With that,
Twix
thank you
is
again.
better, but I'll stick with Twitter because that's what I know.
Yes. Yes. Thanks
Thank you
again.
so much, Corneil.
Appreciate everybody
That
for
was a
showing up
lovely
live,
conversation.
and we'll
And
do it
thanks
again
for all
next
the
week.
questions.
Yeah.
And Go
Thank
well,
you so
guys.
much. All right.
All right. Thanks a
Take
lot,
care.
everyone. Have a good one.